Hi, I'm Victoria Alexander, and I'll be teaching a course this spring at IPAK-EDU called The Perils of Coding Humans, a response to transhumanism. I've created this course for people who may have heard about the fourth industrial revolution and how scientists want to genetically re-engineer bodies to totally eradicate disease and even augment intelligence. I think the people who will be interested in this course are, on the one hand, those who think that this sort of thing is just not possible, and on the other hand, those who think it is possible and are afraid of what some people might do with the new tools that are being invented. We all need to be better prepared to engage in this discussion, no matter where we are coming from. We need to know what the current arguments are and what the history is so that we don't fall silent in the face of experts who say that humans are hackable animals or that DNA is just like computer code. For hundreds of years, philosophers and biologists, and more recently, computer scientists, have been debating these kinds of questions, and the history is really complex. But what most people hear about is only the current, very narrow view on the question. For years as a researcher, I've been describing the differences and similarities between the way that organisms process information and learn new things and the way that computers do. I started out studying creativity and art forms. That led to more general questions like, what is creativity in humans or in nature? Now I work in an interdisciplinary field called Biosemiotics, which grew out of complex system science. In this course, I'll draw from literature as well as science, and I design and offer the course this way because I think it's important to place science within the larger historical and cultural context. On the IPAK website, you will find the syllabus and a more detailed course description. And let me tell you a little bit more about some of the topics that we'll be covering each week in class. For week one, we'll start with the most general overview of the argument between the reductionist and the anti-reductionist. Most so-called free will arguments turn on whether or not there is chance in the universe that supplies us with a kind of freedom from constraints. Well, what is chance? The answer is not that obvious. And throughout history, the definition has changed drastically, and today, the definition can be different depending on what discipline you're in. Next, we'll explore how DNA really is like an encrypted code or a conventional symbol. But how is DNA different from a code made by a computer programmer? For week three, I'll introduce biosemiotics. The idea is that biological cells have the ability to respond to chemical signals, the signs, because during the course of evolution, they've come to associate the sign with some useful process. We will think about how this makes it possible for scientists to fool the body, as well as makes it possible for the body to respond unpredictably to interventions. Building on what we've learned about biosemiosis, the next week we'll explore how propaganda takes advantage of the way the subconscious part of the brain processes information when we're not really thinking. And we'll contrast this to the way that art tries to call attention to the subconscious process of meaning making. Current computer neural networks don't model the subconscious, by the way. For week five, we'll learn about Alan Turing's theory of machine learning. What is the selectionist, the trial and error approach to learning, and how has computer science evolved since Turing with, for example, deep learning AI? For week six, we'll look at post-war cybernetics and how researchers found that instead of precisely pre-programming for every unique situation, it was better to make machines that can react to the environment in intelligent ways. We'll have a guest lecturer that week, an electrical engineer and a biosemiotician who will talk about what a cybernetic model of a creative agent might look like. On week seven, we'll look at the possibilities for artificial evolution. If you thought AI was worrisome, just wait for AE. We'll have another guest lecturer who will ponder what might happen when humans start guiding their own evolution or invent AI to augment the process. Next, I've done a lot of work using slime mold as a model of cognition. And on week 8, we will explore the question, Which is smarter, slime mold or computer bots? On week 9, I'll introduce you to one of my favorite topics, reaction diffusion and self-organized patterns. Sounds boring, but it's really cool stuff that comes out of Alan Turing's work in morphogenesis, which he was doing right before he died and which made him rethink his initial theory of how brains organize themselves. On week 10, I'll introduce you to the argument that evolution might not always be gradual and might not always be driven by selection for fitness. We'll consider why Vladimir Nabokov thought that some forms of insect mimicry could have evolved suddenly in a generation or two, instead of being gradually refined by selection. I'll also tell you why Alan Turing may have offered the theory that proves Nabokov was right. Sticking with the literary theme, in week 11 we will consider novelist Thomas Pynchon's deep interest in conspiracy theories, spontaneous self-organization, and American semiotician C.S. Peirce, which he writes about in his 1966 novel, The Crying of Lot 49. That should be fun. Next, for week 12, we'll explore the idea that there may be sources of biological novelty that are not random with respect to the needs of the organism. And for week 13, we will come back to the question about chance, and we will look at how Milan Kundera expressed his theory of genetic determinism in his 1991 novel, Immortality. On week 14, we will again return to our initial question about chance and mechanism. This time we ask, if biological organisms can only negotiate their worlds in terms of their existing evolved programs, how could they ever learn anything new? For our last session, I have planned a review, and we will talk about what we can do with the information that we've learned from class. Our generation is poised for a cultural revolution that will help us create a better climate for science, education, medicine, agriculture, and the arts. That revolution will play out around dinner tables, during coffee breaks, and in comment sections. What I am offering my students are the tools to influence culture just by taking a more active part. The people collectively create culture. We can do that just by changing the conversation with family and friends and coworkers. It's up to us. So what's a fun fact that I can tell you about? 20 years ago, my dissertation advisor, Jim Crutchfield of chaos theory fame, defined nonlinearity for me in a way that I found really useful. It's said that nonlinear systems are inherently unpredictable. And the standard way of illustrating this idea is to point to the butterfly effect, where you have a small input like the flapping of butterfly wings in Brazil can have a large effect 2 weeks later, causing a tornado in New York. Well, that's a bit misleading. And so Jim put it this way. Your ability to predict the behavior of a complex system, like a human being, does not improve in proportion to the amount of data you've collected. So one of the consequences of this is that there is no justification for the massive data collection on us. There are other ways to improve predictions of complex systems. And big tech people must know this, which leads me to guess that the real point of big data surveillance is censorship and narrowing your options so that they can control what you choose, not predict what you choose. The course starts January 9th, a Monday at 12 p.m. New York time, and we'll meet once a week for a discussion, a lecture, and some fun voluntary homework assignments. You'll want to register for the course by going to IPAK-EDU.org, click Course Listings, scroll down, find the course, and click to pay. If you're looking for the full course description, you can click on Registration, find the course by scrolling down to page 2. In the course description, you'll find my bio, or you can go to my website, bnalexander.com, if you want to read some of my work. See you in class.